We need to introduce an idea that is often a stumbling block for people, but I don't think it has to be. The term is limits. Here's the big idea about limit. When we look at a graph, we look at an x value, we could actually look at two different things. The first is we could look at the y value at a particular x value, or we could look in the trend in the y values near that x value as we get x values that are closer to a given x value. Is there a definite trend in the y values? And these are actually two different things. If we look at the y value, that's something that we've seen before. The y value at a given x value determines the function, the f of x value at that x. But the definite trend in the y values near but not at a particular x value gives the value of the limit at that x value. And this is the new terminology limit that we're going to be introducing right now. So here I have the graph of y equals q of x. This is my function. And I can see there's this discontinuity where the function suddenly, for some reason, jumped at x equals 0. And even though it looks like it should be, the function should be taking the value of x equals 1, it's really the case that at x equals 0, q of 0 is equal to 2. We have a way to say that. When we say q of 0 is equal to 2, that's coming from the fact that there is this closed circle exactly at 0, 2. Because there's an open circle at 0, 1, it's not the case that q of 0 is equal to 1. That's an open circle that says look somewhere else. But it'd be really nice if we still had some way to talk about the fact that this behavior was unexpected. So can we describe this in a different way? We can't say q of 0 is equal to 1. That's not true. But we definitely noticed a trend in the y values as x was close to x equals 0. As x was really close to x equals 0, y got really close to y equals 1. We noticed this trend and we would like to describe this trend now. So what we say is the limit as x approaches 0 of q of x is equal to 1. To describe this behavior that we saw, the way we write that in symbols is like this. We use something called lim, and then we put x approaching with an arrow, the number we're approaching. The function is equal to the y value that it's approaching. So limit as x approaches 0 is in this piece, of q of x is equal to this piece, and is equal to 1 is captured in this piece. The big idea we need to get across is that this function value and this trend can be two different things. So we just saw a graph where these two things are different. In this q of x function, as x approaches 0, we get different behavior than we see when we look right at x equals 0. This is the graph of g of x, and we're going to first ask, if this is the graph of g of x, what is g of 0? In looking at this question, the answer is g of 0 equals 4. And we can see that from the fact that there's a point at 0, 4. Now let's ask a different question. What is the limit as x approaches 0 of g of x? As we get really close to 0, it might look like we're heading towards the point 0, 1. And even though that point isn't actually on the graph, that looks like where we are heading. We can try to make a table to confirm this. So let's plug in some values that are really close to x equals 0, and let's do it in such a way that the values are getting closer to x equals 0. And it looks like as the values get closer to x equals 0, then y gets closer to 1. And I've investigated this both from the left side with values that are smaller than x equals 0, and I've also investigated it from the right side where I'm looking at values that are slightly larger than x equals 0. So here the left-hand side is in red and the right-hand side is in green. So when the graph isn't completely clear, we can create a table to help us estimate the limit. But it's important to note that that's an estimate. It won't give an exact value. Let's look at one more. So let's look at f of x, which is going to be equal to 3x plus 1 if x is not equal to 0, but it's undefined if x is equal to 0. So what is f of 0? F of 0 is undefined. It says so right in the formula. But even if it didn't, we can also see that it's undefined because whoever made this graph was nice enough to put a big open circle at 0, 1. Tell us there's a problem here, and this is not value that you might expect it to be. But the limit as x approaches 0 of f of x is 1. And we can tell that because if x is really close to 0, but not right at 0, then the y is really close to 1. Even though it's not at 1, that doesn't matter. This yellow thing is what we're investigating. And so I can zoom in really big, and I can see there's this point at 0, 1, and as x gets really close to 0, y gets really close to 1. It doesn't matter which side I come from either, the trend is there, regardless of the direction. Even though the function is undefined at x equals 0, the limit as x approaches 0 of f of x is equal to the value of 1. It's totally possible to have a limit even if the function is undefined at a particular place.